is Jessica Son.
My name is William Ramsey.
My name is Nicholas Clark.
And our project for Intro to Mechatronics is an Orchid Guardian. So our system is only really used to help monitor an orchid life. Essentially, we integrated essential sensors that helps monitor some of the properties such as temperature, light, presence, other important properties to make sure that it can alert us when something is out of place. All right, so I'm gonna now be talking about the essential parts and the sensors that we used for this monitoring system. So over here we have our system pulled apart. The Orchid Guardian is supposed to be in this container, and then we have these individual holes. But since we are gonna have to be talking about the connections and the parts used, we took it out. So the main parts we used over here, this is our button, and we just have to put it together to operate the system. Okay. And then over here we have our microcontroller. This is the Eleglu Uno R3, and this essentially allows for digital inputs and power to be working in our system. And we have our breadboard, and this allows for a positive and a negative voltage charge to run the actual microcontroller and the parts itself. So over here we have our resistors, and we have the passive buzzer, and this allows for a sound to be made when it detects presence. And over here we have our ultrasonic sensor. This is our sensor that monitors motion. So whenever it detects like an animal or a baby or something, it can start to alarm. And then over here we have our potentiometer. This allows for resistance to be adjusted. So this affects the LCD display over here. And LCD display will show the properties like temperature, water level sensor, etc., so that the users can view it. And then over here we have our LDR light dependent resistor, and it is connected to like the 10K ohm resistor. So essentially this just measures the amount of ambient light the Orchid receives, and it uses that voltage divider by the 10K resistor to convert raw analog inputs into a percentage to determine if the Orchid is receiving enough indirect light. Okay, and moving over here to our Orchid plant, we have our water level sensor. And so the water level sensor will display the percentage over here on this LCD display. And then we also have our temperature sensor. So this basically gives us readings for the water temperature of the Orchid bowl. And over here we have our like LED displays. And this basically, all it does really is it starts to light up whenever we have like sufficient enough readings. And so if the properties of the plant is good, then it'll stay green. And if something is out of place, like for instance, the water level is low, then this will turn red.
Hey, my name is Nicholas Clark, and I'm going to be going over the connections and giving a brief demonstration on how the Orchid Guardian works. Okay, so the first thing we're going to be going over is the initialization screen, which just gives this brief message whenever it's booting up. So the LCD display cycles through 4 different readings on a 2-second basis. So it shows water level, light level, temperature, and it also shows humidity. There's also code on the Arduino that has thresholds for the temperature, humidity, water level, and light level that are optimal for orchids and their growth. You also probably noticed the green RGB LED we have connected right here. This is an LED that can change color based on the input that you give it. You can see where it's connected to the breadboard with the 220 resistors, and basically when it's green, none of the levels are without the threshold, so they're neither above or below the optimal percentage of humidity for the orchid that we have here. Okay, next we're going to go over the alarm system here. So I have these two wires right here in place of a push button because they actually work a little more reliably than the push button. So I'm going to connect this and you get an armed message as well as an A in the top right to warn you that the system is armed. When the system is armed, the ultrasonic sensor over here is programmed to trigger an alarm system whenever something comes within 10 centimeters of it. So maybe if you want to walk away from your plant and your cats or animals are bad about knocking plants over or being destructive, this alarm will either scare them away or at least alert you that they are close to your plant so you can shoo them away yourself. So I'm going to do that right now by slowly having my hand approach the surface of the ultrasonic sensor, and you will see the light here change as well as the passive buzzer that we have hooked up right here. So that alarm played for 5 seconds and automatically shut back off. If I were to place my hand in front of the ultrasonic sensor again, it would sound the alarm. But this A right here is a status letter. We also have 4 more of those that can show up in the bottom right here. So just like how it's green right now with absolutely no problems, if there is any problem with the plant, this light will be red to grab the user's attention. And we have 4 boxes in the bottom right here which have warnings for water, temperature, light, and humidity. So you'll know what's wrong with it without having to compromise your constant feedback on your different levels within the tank. We decided to go with a passive buzzer because an active buzzer worked, but we noticed that the passive buzzer has a tone function in the Arduino code, and the tone function allows us to give a lot more different sounds because you can use different frequencies to create different trillings or different tones that you normally wouldn't be able to produce with a regular active buzzer. We also have the LDR right here, the light detecting resistor. So right now we are in a good threshold of light for the orchid, but I'm going to place my finger over it, and you can see that the light turns red and we get a warning L on the bottom right of the screen, meaning that the lighting for the orchid is not optimal right now. This potentiometer right here is hooked up to a hot wire right here on the breadboard and a ground wire right here, and 5 volts flows through it, but as you twist it, it changes the resistance, making the contrast on the LCD display change. And if you take this pin out, it won't work anymore, and it just kind of depends on the lighting that you're in, how you would want to adjust it. So one of our last peripherals here is the water level sensor and the DHT11 temperature and humidity sensor. These ones actually probe into the bowl, and right now you can kind of see the water level sensor is sticking about halfway out of the water. And so for this particular orchid, the amount of humidity that it needs, that is about, 88% of what it requires. The DHT11 here also sits in the bowl because it needs to know the ambient humidity within here because it's very different than what's outside the bowl.
My name is William Ramsey, and now I'm going to be going over the code for the Orchid Guardian. All right. At the beginning, we have the include section where we include different, where we draw stuff from the Arduino library that we need, like the liquid crystal for running the LCD. And down here, we literally shows that where we label the LCD variable that we use later on in the code. Here we state the sensors, the pins for each different sensor, and for this is the water sensor. Down here we have the DHT11 setup sensors, showing where they go for each pin they go to. Down here we have the even more for each individual sensor. We go over and assign them to each pin as it goes down, and even the button, and basically every single outlet goes to for each pin of the Arduino. We set it aside here. Now, here we start going over the thresholds where we set aside for every single component of the Guardian. Starting with the minimum and maximum for the thresholds for the water sensor. And here, as you can see right here, the water threshold for the sensor gets right here. And then right here we start for the thresholds for humidity, the thresholds for temperature, as well as the thresholds for light. Here we have a variable set aside for the screen switching, because we want to have some sort of delay between each different screen and each different mode. And right here we have the timing and the cache for each different thing for that. This is the cache for the ultrasonic, and this is the Boolean to activate the alarm and show which mode it is in. Here we have the alarm cooldown, where we used unsigned long function and the constant unsigned long function to set a cooldown for each thing. We have the ultrasonic distance. This sets that up completely to set the distance for each, the minimum distance and maximum distance that you can activate the alarm. Over here we have the function that activates the red, green, and blue lights, so you can have control over that. Over here, this has better, allows us to have more action and control over the alarm behavior specifically, while having delay, while having the light flashing on the LED, and also the sound for the buzzer. Okay, and here we have a function that also helps for reading the button. It's a very long, very depth function. Over here, we have finally get to the setup of the actual program, where it runs each and every single one of these functions that we previously set up. And here, and we go through here, and it also sets the time. Now we get to our main loop, where we loop through all of these functions and it reads through all of them, making sure. So here, this one handles the which mode it's in. This one reads the water level. This one reads the of the light level. This one reads the humidity and the temperature. This one reads making sure each value is correct and in the correct parameters that we're supposed to have it in. And then we translate the temperature and the statuses onto the LCD display. This is for the temperature logic, make sure it is in the correct parameters, the logic for make sure the water is in the correct parameters, the light logic, humidity logic, and then it sets the RGB light depending on what quality it's in. And then this is just a very simple if-else statement, then ultrasonic distance monitoring, alarm condition, LCD screen, switching the time and delay stuff. And then it clears the LCD and it runs through all these, the screen and water level, light level, the temperature, the humidity, the armed indicator. Each of these will go through one by one as it scrolls, as shown earlier, through the LCD screen. And that's basically it.
Thank you everybody for watching our video. We just wanted to give a shout out to UTC and Asaf Varal for getting us to where we're at and letting us use his equipment and laboratories to get this lab done.